Hello guys. So today I'm going to discuss a couple of problems on moments. So let's start with a brief review. From vector algebra, we know that the cross product is defined as a vector perpendicular to the plane of the vectors that we are making products out of. So if we have P and Q in the plane with an angle theta between them, we get a perpendicular vector to P and Q, or let's say the plane that P and Q lies on. And this is the notation. So we show it by P cross Q, and algebraically we construct this 3 by 3 matrix. So on top you have I, J, and K. Second line is the first vector P, then third line is the second vector. So to actually get this determinant, you start with the vector in I, and this is what you do. So you cross two lines that intersect at I, cross the row and the column, and then diagonally multiply the components. So this would give you Py times Qz minus Pz minus Qy. So the result is the subtraction of the diagonal multiplication. And then you go to the next vector J, and then you cross the row and column and then multiply the components on the diagonal components, and then you get Pz times Qx minus Px minus Px Qz. And so the order is such that you start from the component on the top left. So that's what you do. So you pick Px Qz and then subtract Pz Qx, but you have a minus sign for the J vector, and that's why you have it inversed here. And then you have Vz. You can simply get that by this same method. And the magnitude of this vector could be derived from this formula PQ sine of theta, in which theta is the angle between two vectors P and Q. So this is what we know from vector algebra, and this is valid for two-dimensional and three-dimensional vectors. And so we go to statics, then we have a definition of a moment. So we have a moment of a force about a point. So if in 3 dimensions, if you look at the top right figure, if you have a vector in space acting at point A, then we can define the moment of this vector about any point in space. So in this case, we put the origin at O. So this is the point that we want to calculate the moment about. Then we draw the distance vector from O to A, the point that the force is acting on. So it could be any point on the line of action. So it could be A at that point or this point, any point along the line of action. It does not change the results. Based on definition, if we define this moment as R cross F, if we refer to the vector algebra, we know that we can construct this determinant and write ijk, and then write the components of the distance vector x, y, z, and then components of the force vector. And then we can get each component of the moment. So moment is a vector, and we can write moment in components, mx, my, and z. And also, as we had in vector algebra, we can write the magnitude of this vector moment as rf sine of theta. So if this is vector r and this is f, then the theta is this vector here, and so this theta is equal to this angle. And if you multiply r by sine of this vector, you would get d. So d is the perpendicular distance from the origin to the line of action. So as I said, if you change the position of A on the line of action, this d doesn't change. So if I pick this point and then draw R, then this is my F. And this is theta. And still, if you multiply R by sine of theta, you would get D. So the parameter with physical significance is D. D is the perpendicular distance. D is, we can say, the factor of amplitude of the moment. So how the greater the D is, the stronger the moment is about that point. Okay, any questions so far? No questions? All right, so if we have multiple force at point A, for example, here, if we have so if we have F2, F3, then we can write the total moments by simply summing the individual moments. So M, which is the moment of this F about point O, then we can have M2 and M3, and based on the definition, we have RF2 and M3, RF3. So we just calculate the individual moments and then sum them to get the total moment. Okay, Jimmy asks, is R always from the origin, or can it be from any point we find? Well, the definition is the moment about any point. So we just pick this point O as the origin of the coordinate system. So it can be about any point. Doesn't matter. If you were to cross the resultant of those three forces with the position vector, would that give the same? Yeah, so if you could also write this, so this MT here could also be written as R cross R. And this R is actually the sum of the forces. Okay, is that clear? Okay. So I guess we have a problem. Where we have a 20-pound force. It's applied at point A. AB is a rod, and we know the length of this rod, which is 9 inches. So we have a 9-inch rod, and the alpha here is 25 degrees, and we want to calculate the moment of this 20-pound force about point B. So method 1, decompose F into components along AB and perpendicular to AB. So this would be the direction of the components. And method 2, just use FR sine of theta. So here this F is the actual vector applied at point A. So we want to calculate this by 2 methods here. So the first method, we decompose and then calculate the moment of each component about point B, and then add the moments. So I give you a couple of minutes. So for the first method, um, the idea is that if you decompose this force, so let's say this is P, and so this P is passing through point B, and the magnitude R, so this R is AB times P sine of 0. So this R is passing through point B. So the P and AB lie on the same line. So this component does not contribute to the total moment. So then you just need to calculate the moment of Q about point B. Q A B sine of theta. Because this is perpendicular, then this sine is 1. So let's see. Okay, let me see. All right, so you have Q, which is based on this decomposition into these two vectors is 20 times sine of this theta here. Oh, this is different from this theta. Here it is the angle between the distance vector and the force. Here this theta is used as the angle between the force and the Q, this component here. So then you have 20 times cosine of 50, and this is what you get for P. So this sine would give you this P here, and then the cosine would give you Q. So Q is 12.85, and then P is 15.32, and the moments is the sum of the moments of P and Q about point B. And as I said, the angle is 0 for P and it's 90 for Q. And this is the total moment you get. Any questions? Okay. So second method. We want to directly use F R sine of alpha. So without decomposing, we should determine the angle between this force and the distance vector. So, well, it's just a geometry, right? So, this angle here is 25, and then if I draw the parallel vectors, so this is alpha, and this is actually five plus 25. Is that right? Yeah. Okay. Uh, so in 3 dimensions, there's no way other than calculating this cross product. So you, as we had it before, you define the vector as you define the force vector with its direction and its magnitude. So you must be able to calculate this now, and then you calculate the sum of the forces, and then you derive the distance vector from the point of action, from the point of interest to the point of action. And then you calculate the moments. So we can see this procedure in example. So we have a small boat that is hanging from 2 davits. So we have a pulley here at point A, and we have another attached point at the same point. And so we have a continuous cable from A to B, again to A, and to D. So we want to, and we know the magnitude of this tension in this cable, and we want to calculate the moment about point C. So the force that is of concern here is the force at point A. So you have several forces acting at point A. You need to find the resultant of these forces at point A and then calculate the moment about point C. So is the problem clear to everyone? Okay, let's see what you do here. Any progress? Let me know if you want to speak. What's the first step? Free body diagram, right? So at point A, we have a pulley So I'm cutting the cable at sections, and then we have another attaching point that actually attach the end of the cable, and all have the same magnitude. So this is the free body diagram. Any questions about this diagram? Because if you look at the Jimmy, if you look at point A in the figure, you see a pulley, and then you see another point. So not all the cables are attached to a single point. Two of them are over a pulley, and one point is a separate point. So that's why we have T, let's call this TAB, which is a separate attaching point. So we can say this is A prime, and this point is A. So this point here is actually A prime. But all of them are connected to a body, which is yeah. That's why this is a single free body diagram. So all the forces are actually connected to a body, which is this long long rod here from A to C. Is that clear? Yeah, it is small. Any other questions? So the first step is always drawing the free body diagram. It's very important that you fully understand how to draw these kind of diagrams. Here you don't actually care about point B or rest of the structure, because The only important thing here is the force at point A. So you cut the rope and you see 3 forces. And so now the question is, what is the moment of these forces about point C? So you could calculate the moments of each of these forces here, or you could calculate the resultant of these 3 forces and then calculate the moment of that resultant. There's no difference, but well, it's easier to calculate the resultant and do the cross product once. So I give you a couple of more minutes to think about this. Now that you know the free body diagram, it's just that you need to calculate the resultant and calculate the moments. And then we can go to the solution. Okay. Um, so with this coordinate system, FAB is in the y direction, the negative direction, and so FAD, you just have to calculate the displacement vector from A to D and then divide it by the magnitude and multiply it by the magnitude of the force. So we have done this several times before, and so you get FAD, and so the resultant force is FAB times 2, because we have two forces in this direction, and plus FAD. And this is the resultant vector you get. So the distance vector is from C to A, and this is how we usually display the vector from C to A. So A slash C means C to A. So we know the coordinates. The coordinates of point A is, so A here is 0, 775, and 3. So this is this displacement vector. And then now that we know the components of this cross product, we know the resultant and the displacement vector, we can calculate the moment. So for the moment, remember that you multiply displacement vector first by the resultant vector. So it's not F cross R, it's R cross F. So here the force is a resultant force, that's why we show it by R of A. And then you construct the determinant. So you have IJK in the first row, then the displacement vector, and then the resultant force. So you just cross the column and row at point I, do the diagonal multiplication, and then you go to J, cross the column and row, and do the cross product of the diagonals, and K. This is the result. Any questions? Pretty clear, right? Okay, so I'll just give you a brief summary. So first you need to draw the free body diagram. You need to know what is the point of action that you want to calculate the moment. Then draw the free body diagram. So if it's a 3D problem, you need to first calculate the unit vector, the direction vector of the forces, and you need to know the magnitude of the forces. And it's much simpler in two dimensions. It's just probably the angles. Most of the time in 2-dimensionals you have angles, and you just need to calculate the components based on trigonometric relationships. And yeah, then you construct your vectors, calculate the resultant of the vectors, and then use the cross product to calculate the moment. We are done with the slides. So I'm here if you have any questions. We have a couple of minutes left. Yes, yes. Well, in engineering they use different words for, but conceptually they are exactly the same. Uh, July 4th. Do you have midterm on July 4th? So okay, so yeah, we have discussion. Oh no, no. All right, no. I don't think so. Let me see. Let me check the. Well, I'm not sure in summer sessions we have holidays. Let me check the calendar. Yes, it's a holiday, so yeah, we don't have any discussion session on Wednesday. Okay, so because you have midterm next Wednesday, then I might do. Actually, there are two options. I might condense the next session discussion and talk about more issues to prepare you for the exam, uh, or I would record a video of some solved examples and upload it. But I guess I'll do the first. I have to consult this with the professor and then let you know. I let you know about that. That's possible. I was answering Carlos' question. Yeah. Okay, so we don't have any discussion session on Wednesday. Have a good weekend, and well, have a good rest of the week, and we meet on Monday again. Thank you very much.